There were quite a few examples left from the topics that we covered last week. For example, we need to talk about recursion. We need to talk about Java cryptography. We need to talk about, again, multi-threading. And there was one more topic that we didn't talk about last week. Generics. And then we'll talk about a little bit about networking. So there are 4 topics we'll talk about today. Let's start the process with recursion. So my first example that I will create is called Recursion Example. We're not using JavaFX here. It's a recursion example with a public static void main. What do we mean by the word recursion? So it is a process, not a program, a process or a method in which the method calls itself continuously. However, the programmer must write a way to terminate, otherwise we're going to generate an infinite loop. So such a method is called recursive method. So recursion is not really a loop. It acts like a loop. It's simply a method call. And this method call is, instead of calling a different method, it calls itself. Whenever a method gets called, what happens? Where is the call placed? In a special memory called stack. Every new call pushes the previous call down the stack. As the method finishes execution, it is thrown out of the stack and the previous call comes up the stack. Recursion uses this a lot. For example, when a method calls itself, it's not a simple call. It's a call tied to a waiting output. So usually what happens when the call comes back, it comes back with some kind of a value, which then works with an existing value to produce the value for the previous call. And like that, you backtrack all the way through to the first call. Recursion happens in all these places. Let's do a very simple example where recursion has no end. So in order to do that, we will first set up a method. Let's say public static void my recursive method. Right now it's a simple call. There's no recursion involved. If you run it, it makes a single call to recursive method, and the recursive method displays hello once. If you truly want to make it recursive, all you do is, on the second line of my recursive method, you write a call back to itself. Now you will see that it goes crazy, keeps calling itself like crazy, and finally it goes into an error situation where it says, you know what, stack trace, I'm running out of space. So depending on the size of your memory, you may run into this situation after. So the error, most commonly the error is the stack overflow error. That means no more space was found on the stack. And that is something that we want to avoid. We do not want to have a stack overflow. So to have a proper recursive method, we want to be able to have, let's say, static in some kind of a variable that I will use to terminate the recursive calls. So if the value of count is less than or equal to, let's say, 6, then keep making the call. Keep printing the word hello and keep making the call. As soon as it goes past 6, then stop making the calls. So now your program will run for only 6 times. You can display the count if you also want to see the count.